All right, so, oops. Okay, so we're taking notes today on investment problems, and it is very similar to yesterday's problems. We're dealing with money, but it's different. It's a little bit more like those liquid mixture problems that we did a while back. So today's date is 2/26, and what's interesting is that today's information is based on a formula that you learned in 6th grade. So who had Kennedy? Okay, Kennedy called this the pretty formula, the pretty. You guys remember what I'm talking about? The I equals P R T, and this is called simple interest. You guys talked about two different, well, I don't know. You used to talk about two different types of interest. Talked about simple interest, and then there was also compound interest. So for the types of problems that we'll be solving, since compound interest is continually changing based on the rate and when they compound it, when we do calculations regarding interest, we tend to have very simple interest problems. So what we're going to do is go through each of those letters, making sure that everybody understands them. And I'm going to start with actually the right side, and then we'll end with the left side. Who can tell me what the P stands for? Anyone remember?
Is it price?
It's not price. I'll give you a hint. The name of the person in charge at a school is called a principal. So principal works two ways. Principal is the amount of money invested. So like you're giving money to something so that you can make money out of it. What you probably dealt with it more was the amount of money borrowed. So when you invest money, you get rewarded for keeping your money in the bank. They give you a little interest. And the word little is sometimes what we are getting these days on some loans. And some loans, some investments are larger. Depends on if you play the market, and you can get a bigger return on your investment, as they call it. When you borrow money, the banks say, we're going to give you this money, and yes, we expect it paid back by this time, but because we're so kind and generous in letting you have this money to do whatever it is that you need to do, we're going to charge you a little bit just as an incentive to remind you this is really our money. So in investments, we make the interest off the principal. In loans, we pay interest on the principal. So we owe what we borrowed and then some. So with the interest, when we are investing, we get the money we invested hopefully back and then some. So it's a different type of relationship. All right, let's talk about what does the R stand for. What's the R? Not a ratio. Yeah, it's an interest rate. They just use the R for rate, but it's an interest rate. Now, the problem with the interest rate is it's given as a percent, but we can't calculate with percents, so we're going to need to change to a decimal. So you're going to see some elements like what you did yesterday when we were dealing with money, having to create decimals, and then we'll eventually have to get rid of decimals. It's kind of a fun little party. Now, what does T stand for? Time, right? So time is more, there's some investments you make for a short term. And by short term, I mean a year or 2 years. Like there's these things called CDs, and they're not what you listen to music off of. They're certificates of deposit, and the bank has them. And so it's a kind of a short-term savings account, anywhere between a year and, well, it could be up to 10 years, I think. But most people do it for a couple years, maybe up to 5 years. And then they get paid a much higher interest rate than they would if they just keep it in their regular account, okay? So time can be whatever it needs to be, but time is measured in years, always. So if you're given something and it's 6 months, you have to figure out what part of a year it is. Now, in our investments, you're going to hear these words: annual. So what does that tell you the time is in our investments? If you hear the word annual, 1 year. So everything's going to be based on 1 year. So time is going to be 1 for us in these problems. So let's talk about the big guy. Let's talk about I. And he stands for interest. So again, depending on whether you're creating like a savings account, which an investment is, you're getting that interest. If you're borrowing money from somebody, you have to pay that interest in addition to the money that you borrowed. Now, some words that you're going to be hearing in these particular types of problems, so you need to understand they mean the same thing, is annual return, means the interest. And then the one that we're going to do today was annual income. So here's what some people do. They have such a great investment that the interest they make is enough for them to live off of. I mean, these are people who have a lot of money, right? So if you can make enough money just on the interest, you can live off the interest and keep the principal in the bank continuing to make more money. So that's what that annual income. And then sometimes it's just like your parents, when they have to do their taxes, if they have any kind of savings account and the bank gives them any kind of interest, they have to say that's income. They've made that. So, for example, I think mine was in the 200 range off of my small little savings accounts that I have. And that interest has to go back to the government as additional income that I made, because it's not mentioned on my paycheck, because it's not through the school district I'm getting paid that interest. It's through my bank I'm getting paid. So it becomes more income. Okay? All right, so what we're going to do is do an example problem. They all have the same sort of idea how to solve them. We are going to use a chart. What's different is our chart's going to use the formula as the categories we're going to plug numbers in for. And they are a little lengthy because they have to explain stuff. So ours says Tom invested $5,000, some at 11% per year and the rest at 8% per year. His annual income on the 11% investment was $18 more than on the 8% investment. How much did he invest at each rate? Okay, so I'm going to make a chart, and my two categories are going to be the types of investment. So I'm just going to say money at 11%, and I'm going to say money and money at 8%. Now across the top, we're going to write our formula backwards. We're going to write P for the principal, R for the rate. Now, technically, we're not going to need to put in T. Why? I'm going to put it there, but why would it not technically need to be there? How long is this investment for?
It's just one. So
Yeah.
does it have an effect on it?
Yeah, since it's an annual investment, my time is just going to be 1 year, which mathematically is not going to affect the outcome of the product. So technically, with annual investments, you guys do not need to include the T because of the fact that T, annual means 1, and multiplying by 1 is not going to change the answer. So if you just write PR, that's fine. But the ultimate is you need to end with I. Okay? And remember how this works is principal times rate times time is going to equal your interest amount. Okay. So the bottom line is we don't know what we're investing. So we're going to say X for one, Y for the other. Okay? Rate. I'm not going to write the rate as 11% or 8%. I'm going to write it as a decimal. So 11% gets written as 0.11 and 8% gets written as 0.08. The interest in the last column is going to be the product of those values. So X times 0.11 times 1 is 0.11X. And Y times 0.08 times 1 is 0.08 y. Okay, now, I see a big, huge number in the very beginning of this word problem. What's that big, huge number? 5,000. What does 5,000 relate to in the chart? Yeah, it's that P, it's that principal. So I can actually write an equation dealing with principal is the amount invested at 11% plus the amount invested at 8% equals the total amount invested. Okay, so kind of like quantity. So we have a quantity equation, and now we're going to do a value equation. Now I have to read the next sentence. It says his annual income, that's AKA interest, his annual income on the 11% investment was. So what that tells me is I've got an equals, and what I made in interest at the 11%, which is that 0.11x, was, and then it says $18 more than, so that's a switcher phrase, so I'm going to write the plus 18 at the end, the amount at 8%. So the amount at 8% was that 0.08y. Okay, so just like what was happening with the money problems we had, I've got these decimals. I honestly don't really want to work with them, so how would I get rid of them? Yeah, in every one of these cases, you're going to multiply by 100 because percent is based on the number 100. So this makes this equation 11x equals 8y plus 1800. Okay. So now I look at what I have, and what would you suggest we do to solve the system? All of our options are available to us. I would not recommend graphing, just because we've talked about why. So what do you guys want to do? No thoughts? Marlene? Okay, say it. To be honest with you, all of the techniques are available to us, pretty much. Okay, so tell me how I'm going to do substitution, Rob.
You would get the one value by itself,
Okay,
like the x or the y.
okay. You tell me, what do you want to get alone, x or y?
Get y alone.
Okay, so here's my question. Are you talking about the first equation, x plus y equals 5,000? Or are you talking about the second equation, 11x equals...
First equation.
Okay, very smart. He looked for a variable that had no coefficient, and he said, let's get it alone. He said, let's get the y alone. So we're going to subtract x from both sides. So this now becomes y equals 5,000 minus x. So this expression, 5,000 minus x, is going to substitute in for the y in the other equation. So here's where we're at. 11x equals 8 times the quantity, 5,000 minus x, plus 18. So I'm going to go ahead and distribute. 8 times 5,000, well, 8 times 5 is 40, and then there's 3 extra zeros. So we get 40,000. Huh? Oh, thank you, 1,800. I forgot. I'm at 1,800. And then 8 times negative x is negative 8x. And then we have plus 1,800. Okay? So then I'm going to go ahead and add 8x to both sides to get all the x's on the left. And then I'll end up combining the like terms on the right side. So I'm going to take my problem up to here. And so that gives me 19x equals 4,000 or 41,800. Ew, lovely. So notice investments are usually large amounts, so we're going to have some bigger numbers to do some math with. So I'm going to do some long division. And let's see, 19 can go into 41 twice. It's 38 with 3 left over. Oh, look at that. That was easy. 19 goes into 38 twice evenly. And there's 2 extra zeros. So what we get is x equals 2,200. Well, x is how much money was invested at 11%. Now I need to figure out what the y is, so I'm going to substitute it in over here. So this gives me the 2,200 plus y equals the 5,000, and then we just subtract 2,200 from both sides. And we get y equals 0, 0, rename, oops, that's the weirdest 8 I've ever made, 48. So I get 48, oh, sorry, 2. Let's try this. This is the worst math I've done in a while. 4 take away 2 is 2. So how do I write my answer? Tom invested $2,200 at, and we have to list the interest rate, so X was at 11%, at 11%, and $2,800 at 8%. Okay? So all of these investment problems are variations of this. Okay? You're going to get 2 equations because you have 2 unknowns. You may have one that has 3 unknowns. I can't remember. It's been a while since I've done this worksheet. All right, that's it.